Hi there! Today we will talk about the ultrasonic sensor HCSR04. There are several YouTube videos on that, as well as posts in different blogs to show how the sensor can be used to measure distances. But today I want to show you something different than measuring distances. I will show you how to program an Arduino to use this sensor to detect movement, like those ultrasonic sensors that are used for alarm systems. Before continuing watching this video, however, please take a moment to subscribe if you haven't done so already, and consider supporting the channel by using the affiliate link below to buy something you need on Amazon. You'll buy what you need and you will support the channel at no extra cost to you. And of course, another way to support is also through donations, via Patreon or via PayPal. All details are at the bottom of the video description below. And now, let's begin. This sensor is made up of two main components, an ultrasonic transmitter, which is basically a speaker capable of generating frequencies around 40 kHz, and an ultrasonic receiver, which is a microphone basically capable of sensing audio waves with frequencies around 40 kHz as well. Looking at the sensor from the front, the transmitter is the cylindric object on the left, which is also labeled with a T on the PCB. The receiver is the one on the right, labeled with an R. On the same side there is also a crystal used to provide the reference for the internal clock of the circuitry that is located on the back of the sensor. You can see how the circuitry looks relatively complicated. It is made out of 3 integrated circuits and a bunch of passive components. The IC in the center, U1, is an EM78P153S, which is basically an 8-bit microcontroller unit or an MCU. This is the intelligent part of the sensor. The IC on the left, here, U3, is an LM324, which is a quad pump. And this is used to retrieve the signal from the receiver, amplify it, and make it usable by the MCU. The IC on the right instead, U2, is a MAX202, which is an RS232 drive that in this case is used to drive the sensor's transmitter. This device is sold for just about $4, but if you had to make it from scratch, given the complexity, it would cost you much more than that. We really need to thank those who invented the concept of breakout board for this. The circuit works this way. First, it needs to be triggered with a 10 microseconds pulse on the trigger pin, which is the second from the left. At this point, the sensor will emit an 8 cycles ultrasonic burst at a frequency of 40 kHz, which is outside our audible range. Then the sensor will wait for the echo of this burst to come back and will measure how long it takes to receive it. Once it receives it, it outputs on the echo pin a high TTL level with a duration proportional to the time it took to receive the echo. If we now measure the length of the high TTL level and knowing the speed of sound in the air, we can calculate the distance of the object. This particular sensor is able, with this procedure, to measure distances between 2 cm and 400 cm, or about 1 inch to 12 feet. The obstacle on which the ultrasonic burst is reflected, producing the echo, must stay between ±15 degrees from the center of the sensor, otherwise the precision will be greatly affected. In this project, however, we will use the sensor to detect movement rather than measuring distances. And to do so, we will simply measure distance at regular intervals, and as soon as the distance from the object in front of the sensor changes, it will mean that the object is moving. We will do that by connecting the sensor to an Arduino Uno. Here is the circuit diagram for our project, which I built with Fritzing. Fritzing is a tool to design schematics, PCBs and breadboard diagrams centered on the Arduino board and other microcontrollers. It's very useful when drawing diagrams based on an Arduino, like in this case. So, here is the Arduino Uno on the left side and a breadboard on the right. Of course, if you have another type of Arduino board, it will work too, but you just have to make different connections to its pins. On the breadboard, you can see the ultrasonic sensor with its 4 pins. The one on the left, pin 1, is the positive of the power supply, which requires 5 volts. Pin 2 is the trigger pin, pin 3 is the echo pin, and pin 4 is the ground connection. You can see that pin 1 is connected through a red wire to the plus 5 volts power supply available on the Arduino board itself. Pin 2 is connected to the digital pin 11 of the Arduino Uno, which will be used to generate the trigger signal. Pin 3 is connected to the digital pin 12, which will receive the echo signal. And pin 4 is connected to the ground of the Arduino board. There are 2 more components in this diagram, an LED and a resistor. The LED will be used to show that the circuit has detected movement. It will turn on whenever the Arduino detects a change in the distance of an object. Note that the Arduino will only look at the changes between 2 different readings. It will not care to provide an output of the distance. The 220 ohm resistor is put in series to the LED anode to limit the current through it, and goes to the digital pin 13. The LED cathode instead is connected to ground. I could have just used the internal LED already connected to digital pin 13 for this experiment, but that LED is very small and difficult to see through a video camera or over a distance. I instead used a big 10mm red LED, which is much more visible. Also, if you happen to use another type of Arduino board, you might not have that on-board LED. In that case, the external LED will be essential. Before writing the program for the Arduino, we need to install a new library on the Arduino IDE. To do so, we go to Tools, then Manage Libraries, then we search for New Ping in the Library Manager. Once we find it, we can also look for the additional information that are available on the web by clicking on More Info, right here. You can see that this library has a very comprehensive documentation, which you can refer to for other projects. Here, for example, you can see all the available methods and also the constructor, which will allow us to create the software object for the sensor. To install the library, we just need to click on the Install button and let the library manager do the rest. Once the library is installed, which we can see from the word Installed written in blue, we can close the window clicking on the button down to the right. At this point, we can go ahead and write the program. We start writing the program for the Arduino by including the library we just installed. Then we define the pins that will be used for this project, pin 11 for the trigger, pin 12 for the echo, and pin 13 for the LED. We also need to define the maximum distance at which the sensor will make effective readings. I am putting here 400 cm, which is the max range for the HC-SR04 sensor, but for the real applications this number may need to be readjusted to tune the precision of the readings. Another thing to define is the delta that defines the movement. We have said that instead of considering absolute distances, we will consider changes of distance between one reading and the next. This constant defines how big the variation must be before we say that a movement occurred. I set this number to 10 cm. However, if you require more sensitivity, you can reduce this number up to about 3 or 4 cm. Don't go lower than that, however, because the intrinsic sensitivity of the sensor is 2 cm, and anything too close or smaller than that won't be good, because it would lay in the error range of the instrument itself. Vice versa, if you want to make the device less sensible to movements, you can increase the 10 cm to something a little bigger. Not too big though, otherwise the object in front of the sensor would have to move really fast to be detected. And that brings me to the last constant, the delay between readings. In fact, at the end, the ratio between the sense distance and the delay establishes the minimum speed at which the object must move to be detected. Let's also not forget to add a few comments, so when we can look at this program again in the future, we can recall what this is all about. Remember that if we need to tune up these values, thanks to these pound defines, we can just come here at the beginning of the program and change these numbers, without having to go through the whole code. And now that we have defined all those constants, we need to create an object that represents the sensor. We do that this way, where I call the object ultra, to recall the ultrasonic nature of it. And we need to tell the constructor of the object which ones are the pins for the trigger and the echo, and the maximum distance that we decided to use. After that, we also need to define a variable that will store the last reading made through the sensor, so it can be compared with the current one. We define the variable as an unsigned int, because that is the variable type that the Arduino reads from the library. Let's go now to the setup function, for which I am removing the unwanted comments. We need to do just a couple of things. Everything else is done already by the new ping library. First, we need to define the pin to which the LED will be connected to as a digital output. Then, we want to initialize that output to 0 to make sure that we start with the LED off. And now let's write the loop function, the one that will run over and over and that will do the intelligent part of the program. So first we define a variable to store the reading of the distance that we are making in the current loop, as opposed to the other variable we previously defined that stores the reading from the previous loop. And then we also need to define the variable where to store the delta between the old and the new readings. Now we make a new reading and we store the information in the variable distance. Then we calculate the delta based on the new and previous distance and taking the absolute value, since we don't know and we don't care whether the object is getting closer or farther away from the sensor. Then we test the delta against the delta we defined at the beginning, the sense distance. If the delta is greater than that amount, then the object has moved and we turn on the LED. Else, if the delta is smaller than the defined amount, the object has not moved, and therefore we turn off the LED, just in case it was already on. And finally, we store the new value in place of the old one, so to get ready for the next loop, and we wait a little bit before running the loop function again. Let me now save the code in a file. I'm going to put it in the same place where I keep all the other files to make this video for now, and I will move it later to someplace else. Let's now check the code and make sure it compiles fine. We just need to push this button. And good, everything seems okay, so now is the time to go to the lab, build the actual circuit, upload the code, and test everything together. And here is the circuit I just mounted to show the functionality of the sensor in this configuration that is used to detect motion. The sensor has 4 pins named from 1 to 4, right, visible over here. 1 is the one here on the left, and then 2, 3 and 4 is the one on the right. The pin on the left is the positive of the power supply plus VCC, which I have connected to the pin that provides the 5 volts power supply on the Arduino board. And then the second pin is the trigger 1, which I have connected on the digital pin 11 of the Arduino board. Then the pin 3 is the echo pin, which is connected to the pin 12 of the Arduino board. And finally, the last pin, the 4, is the one that connects to ground the sensor, and so it's connected to the ground of the power supply of the Arduino board. I have also this LED. I choose a bigger one so you can see it better, and a resistor of 220 ohms. The resistor is connected here on pin 13, and then from there goes to the anode of the LED, and then the cathode of the LED goes to ground directly on the Arduino board. Okay, now that we have everything set on the board here, let's upload the program to the Arduino board. So we just need to click on the upload button over here. So it's uploading now, it's done. Okay, so now we should be able to test our circuit and see how it works. To do that, to avoid issues from the bottom here, I'm gonna put this on top of it. There we go. And now I'm gonna use something in front of it. There we go, like this. Let's see if I can hold it still. So now when I move this board, this blade here, we should see the LED going on. And you see, that's exactly what happens. Every time I move, the LED goes on. So this is a way basically to detect motion using an ultrasonic sensor like this one. And you have it. We were able to use the HC-SR04 as a motion sensor, although it was thought to measure distances. Many times in electronics, we reuse components to do something that wasn't in the mind of the original designer, but that is exactly what it means to be an engineer, right? Next time I will use an Arduino will be to do something completely different. I'm going to recreate a science fiction object that I'm sure many of you will recognize from the original movie and later TV series. Can you guess what it will be? Write it down in the comments, as well as writing your thoughts on this motion sensor project. Thank you for watching, and as usual, happy experiments!